Hello and welcome to the Grid Podcast, your podcast about our electricity networks and their role at the heart of our transition to net zero. I'm in the hot seat today. It's Brian Moorhead hosting with regular co-host David.
Hello.
And today we are talking about a topic we get asked about a lot, and that is behind the meter connections for generation, storage, wind. And before I go any further, just what is behind the meter? Lots of people have lots of different lingo. So it could be a large factory looking to install some solar. It could be an EV charging hub combining with battery or solar or a combination of both. Some people know it as zero export or limited export connections. There's some people know it as private wire. That's another term that gets thrown about, a private wire connection for a solar farm. So it's really just combining a load or a demand factory, EV hub, anything at all, and directly wiring in some generation, usually solar and battery, wind turbines occasionally, geographically doesn't suit as much. And this is something we get asked about a lot, especially now with the transmission capacity crunch now, that we've mentioned in a previous podcast episode. If you're looking to just do a greenfield solar site, export into the grid, anywhere in GB now, you're looking at 2030 sort of and beyond connection dates. So lots of people have been turning attention to, well, actually, could I develop a solar farm beside a large factory, or even just energy pricing going up as well. Lots of industrial users are looking at this as well.
And that's kind of the essence of the engineering, isn't it? The load beside the demand means you don't need as much distribution or transmission network in between. So it's kind of the ideal scenario in some ways.
Exactly. So it's all about industry kind of decarbonising, becoming more self-sufficient as well. And then even a lot of people are approaching us about it on the basis of they can't get capacity. Maybe it's for an EV charging hub or a large industrial connection, and they're asking, well, is there anything we can do with batteries or solar or anything to alleviate those grid issues, even in the short term? So it's something that's quite a hot topic in the industry at the minute, but it is also something there's a lot of misconceptions about, and it often trips people up. They think, well, sure, I'm just generating and using the power on site. Why does the grid? It's none of the grid's.
Why does it matter?
Yeah, it's none of the grid's business. It's none of the DNO's business.
So a few things maybe that we'll cover today then. Your legal obligations, to actually have permission to have this behind the meter scenario. And then we'll get into why actually there are those obligations and the technical reasons behind that, just at a high level, even though you're not exporting. There'll be some differences, between what behind the meter looks like than, say, an export connection, or indeed even your import connection, and who you need to keep, update it and what you need to consider. And then really, we need to we'll provide a sort of summary of, here's all the sort of checklist stuff that you need to do to make sure that, we've done that. Yeah, we're fully compliant. We know what we're doing, and that you get the most out of your behind the meter connection, because ultimately that's what the customer wants, isn't it? Is that they want to be able to have an economic and a commercial case back that enables them to save some money and reduce their carbon footprint.
Exactly, and it's as much about being aware of a lot of these risk items before you go too far down a road. I think we've seen lots of these projects. It always sounds like a great idea on the face of it. That there's maybe a large solar development in a local area or something else. But, there's lots of different risks, as we'll get into, lots of different potential impacts here. So as long as you're aware of them, you can manage them, you can mitigate them, and you're much more likely to have a successful project.
It's probably worth saying too that ultimately greenfield sites probably easier to do, because you can consider all these things as you're actually designing, your connection, designing your switch gear, your network or whatever beyond the meter. But there's a lot of people looking to do them retrospectively, rightly so. But that adds a wee bit more complexity and probably just a little bit more stuff to consider. So we'll talk about those couple of things. We're really concentrating on the larger non-domestic type market. But if you are a domestic user or a small sort of industrial, commercial, local SME, certainly the main principles will still pretty much apply across, what we've said today. So you can take those as a first cut, and you still, yes, even at that level, you still need to have some form of interaction with the DNO. Yeah,
the legal obligations are similar. The technical reasons are all similar. There's just some slight different, like fast track processes and stuff for domestic and, sort of smaller scale industry as well. Okay, well, that's us teed up. I suppose we'll get into it then.
So legal obligations, Brian, where do they sort of ultimately stem from, or what's the...
Yeah, so anybody, the first thing they need to know if you're looking to put any behind the meter generation, this applies from, sticking solar on your roof and anything up to large scale solar farms, battery plant. It's ESQCR legislation, so the electricity supply, quality and continuity regulations.
Easy for you to say.
If I haven't got that right in the podcast, I'm going to get torn to shreds, so I hope I have. Basically, there's a clause in there that if you are operating generation in parallel with the grid, so that this key phrase in parallel, and before going any further, what does that mean? It means that you're electrically connected to the grid while your generator is running. So that is different to like if you do live out in the countryside and you've got a backup generator, likelihood is you'll have a changeover switch at your meter board. So you switch it over and you're totally electrically disconnected from the grid, and then you start up your diesel generator.
They normally call that island mode, don't they?
Yeah.
You're a wee island on your own. You're not connected to anybody else. You're just this one generator feeding this small bit or small island.
Yeah. So that is not in parallel with the grid. That if you're on a changeover switch, you're not in parallel with the grid. This does not apply then. But it is very, very rare. That happens. Backup generation at a domestic level. When we're talking about plugging in solar farms and large battery plants, or even if it's a megawatt of solar on the roof of a large industrial factory or something, you're not going to be able to turn the whole factory off and just run it on the solar.
Yeah, but even back in the day, the network operators and they still do this. If they're providing generation, say in a fault scenario, or actually more likely for planned maintenance, they want to keep their customers on. They'll parallel their generator on with the grid first, and then they'll disconnect it. So that's a common principle right across.
Yeah. So the word parallel is you're operating and you're still connected to the grid. So you could be importing a little bit of power from the grid and using a lot of power from, say, your solar panels or your battery, but everything's electrically connected. So you have to obtain permission from the DNO for that. And I think that the threshold's 16 amps per phase. It roughly works out about 4 kilowatts per phase. Below that, is your domestic scale. There's fast track processes, but anything above the 16 amps, then there needs to be express permission from the DNO. Now that's set out in legislation, and I suppose it's really there because of the technical reasons behind it that we will get into. And it's that question we keep getting asked. Why is it any of the grid's business? Like, say you're on a zero export connection where you're not exporting anything, you're just using the power on site. Like, why does the DNO need to know?
Yeah.
And that brings us really to the next topic: is fault level. So,
yeah, I mean the main thing in that ESQCR is the safety element, isn't it? That's the real critical piece of this.
And that's why it is there. It's there for safety reasons. And when we explain fault level and the fault level impact you might have, that hopefully will make it clearer why there is a reason there.
Yep.
So I suppose just to get into it, we'll probably not have enough time to explain fault level from first principles. But in a nutshell, you're connected to the grid and you've got an export limitation device that is set to 0. So you're not exporting to the grid, you're just using the power on site. Well, what impact are you having on the grid? If there is a fault on the grid network, your generator will still contribute fault current to that fault and to the DNO's network. And fault current could be 3-4 times the power rating of your generator. So if you've got, say, a 1 megawatt generator on site, it could contribute 2-3-4 times its rating into the DNO's network, into the fault. And the DNO has to, they manage fault level on their network. So they've got all their circuit breakers, all their kit that protects the network. When there is a fault, it isolates the dangerous bit of network and makes everything safe. Those switches are only rated to a certain fault level, so there's only a certain amount of fault level they can break before you get catastrophic failure, I think is the PC term for it. So by connecting your behind the meter generation, you are going to be increasing fault levels on the DNO's network. So it is always like number one thing I recommend to anybody, if you're going to go for any sort of scalable behind the meter generation, is fault level checks upstream in the DNO network and potentially downstream, depending on what way.
And a lot of the DNOs have those on like sort of heat maps now, nearly, don't they? Some of them have, certainly.
Yeah, you can check quite a bit of that.
Yep.
There's quite a bit of data out there, so have a quick fault level check. That is probably the main issue that might trip you up. And because the networks are now so saturated, any generation contributes fault level. The networks are so saturated with distributed generation now. Fault level it is becoming a bit of an issue. You are seeing fault level issues, and it typically means the DNO has to replace a full substation, which takes years to do.
And historically, it is probably, the fault level is probably on the older switchgear. The newer stuff is generally, as a general statement, will have a higher fault level rating.
Yeah. And I suppose one thing I have been asked quite a lot, well, is there no solution to this? Well, you potentially can do a little bit of fault level mitigation at your site, but at the end of the day, there's no way to totally mitigate it. If you've got no fault contribution from your generator, then you can't safely operate that generator yourself because you can't design your own protection.
Yep.
So fault current's a necessary evil in a way. You need a fault current to detect a fault to be able to run a safe electrical system. But at the same time, once it gets too high on that system, it causes issues and you need to upgrade your equipment.
Yeah, and as you say, all generators have some level of fault level contribution. Sort of in the scale of things, higher level fault levels to lower level fault levels. Solar, compared to like a traditional generator.
Yeah, well, solar's going to be at the lower end of that in terms of any inverter connected generation. Obviously, your sort of spinning machines are going to have much higher fault levels. But I think, without going into the full nuts and bolts of fault level, just kind of high level explanation, that is one of the key impacts you're going to have. It's one of the key things to check out. And if the local network is already maxed out for fault level, there's a good chance you might have to wait for a full substation upgrade, which can take years.
The other thing from a safety point of view, though this is easy dealt with, from a protection perspective, is that you have to have a loss of mains protection as well. So if you kind of think of if a circuit trips and there's generation downstream and it's actually then islanded from the rest of the network, what the network operators can't have is generation feeding back onto that network and making it live, because they're thinking about sending people to work, all the rest of it. So the loss of mains then comes into a requirement as well, but say much easier.
Yeah. Well, potentially, I suppose it depends on the size of your scheme. If you're into some very large generation, say you're putting basically a greenfield solar site into private wiring it into a huge factory, a lot of the DNOs would have maybe like intertripping loss of mains requirements and things like that. So
fair enough.
You can be into quite maybe complex communication schemes. So, I suppose that's really the next one after fault level is, there could be a need for protection upgrades. There could be a need for compliance upgrades. So say you've got an existing factory, it's got a 10 megawatt load, you're maybe sticking a 5 megawatt solar farm in next door, you're going to private wire it in. Your whole connection's going to need to be G99 compliant. You're going to need to be G100 compliant. So I'll touch on G100 in a bit more detail. G100, everybody will be familiar with G99 sort of generation compliance standards. G100 is the ENA standard that governs export limitation schemes. So if you're doing any sort of export limitation, whether it's partial export or fully zero export, your site needs to be G100 compliant. And that's basically an ENA policy setting out how your export limitation scheme needs to work, different thresholds and everything else. And you might need some of that loss of mains protection in there. So that this can get a little bit complicated, particularly if you're going into retrospective sites, because you might have some old switchgear in there that's been sitting there since the 60s. You maybe don't have VT signals for the likes of MVD protection, or you might need new CTs. You might need new circuit breaker bays in your private gear to terminate your cable into. All of a sudden, you can be looking at a full, private substation rebuild and redesign, which you might not have factored in at the outset. You might have said, "Oh, I can build a solar farm, 5 megawatt solar farm. It's going to cost me X.
Stick it in here.
Stick it in. It's all going to be grand." And then all of a sudden, you have to overhaul a full substation, and it's costing you the same as
the farm in the first place, or whatever.
The overall budget's now doubled. So we go back to the start. This is all about identifying all those risks up front so that you can consider this at the conceptual stage when you're looking at budgets, and be aware of it to be able to factor it in before you go too far down the road.
And there has been a revision to G100, hasn't there, recently, which does make it a little bit more complex than it was previously?
Yeah, so the kind of the initial version of G100 then, effectively what it was is a two-step process. So you should have a controller on the site so say it's a zero export site. So you've got 5 megawatt of generation, 10 megawatt factory. But if the factory load drops to 3 megawatts while the solar's exporting to 5, you need a controller then that ramps the solar down. Either ramps the solar down or ramps demand up.
Yep.
To make sure that the power isn't being exported to the grid. And there was a time band allowance to do that, so that the controller had a 5 or 10 seconds to get that to happen. So there's a short-term exposure. Actually, your controller can't act instantly. So this is actually another problem. You have a potential short-term thermal overload or potential voltage issue to the DNO. So your export limiting device may not be able to stop all power export. There may be power spilled to the grid over a few seconds, or in the case of the update at G100, that can run into minutes. So that is another consideration the DNO needs to look into. They need to look into short-term overload ratings, because you could be, even though it's zero export, you could in reality be spilling to the grid still. So that's one element. And then the second stage of the original G100 was basically a trip. Then if the control system couldn't keep the system within limits within a certain time frame, you trip off the generation or trip off the whole site. Which is actually, if you're ever setting up one of these schemes, you really want to design that well. I've seen some really bad design schemes where it trips the whole site off.
Yep.
You don't want to be tripping like a whole hospital or something off.
No, for sure.
You want to make sure you're tripping signals and logic set up right, that you're only tripping the generation. I've seen some really, really bad examples of that. So that's ENA G100. It's got a lot more complex now. They've taken into consideration a lot more different scenarios. That you have different types of plant can react differently,
and how they operate and what their reaction time is and that kind of stuff.
If you think large, maybe synchronous machines can't really operate within seconds, so they've more allowances in there for that, and it's all down to bespoke network studies. What is the local network? What's the risk of overload? So even
generally in the overload question, I know we have the fault level issue as well, but in the overload question, if your generation is less than your demand, you should probably be all right in terms of the network that's out there.
Again, it comes back, like, it does get all very bespoke, because you think you've got a very bespoke local network, so that's going to be different for every site.
Yep.
And what the local ratings are there. And then every site's bespoke. Like, not everything's a solid, like what 10 megawatt factory just sits at 10 megawatts and ticks over. They're going to have variable load profiles. It's probably potentially variable on a daily basis as well.
Yeah.
Whereas, well, I suppose solar's a fairly predictable pattern, so you can look at that quite easily. But even, say, battery storage, you could be using it off and on at any time of day or night. So you kind of need to sit down, look at what the factory or the use case profile of whatever it is. If it's an EV charging hub, well, EV charging hub's going to be a very variable application, as an example. And
I think that very much depends then, we're nearly into a whole other topic here, but like, are you actually load managing your site? So like, if you have a connection that's 10 megawatt designed and you have a 5 megawatt generation, there's going to be a bit of export, generally should be. But then if you're actually on that sort of load managed site, then that becomes much, that's a whole other other thing where you're actually saying my generation's providing me something that I need.
But yeah, so just to maybe come back high level on the technical issues. So we've got, fault level, that's an issue you just can't really avoid. You've got the fact that even with your export limiting device and control system, there's still a risk that you could be, thermally overloading the DNO's network, either on a short-term basis, and potentially causing voltage fluctuation on their network as well. Yep. So that all needs to be looked at in the DNO's network, and it needs to be looked at specific to your application and what you're doing as well. And then obviously if you're on what we would call a limited export scheme, so if you've got 10 megawatts of generation, but you want to be able to spill 2 megawatts to the grid, well, that 2 megawatts is then also going to be treated the same way any brand new export site is, which means you're joining the bottom of the queue, and you're probably going to have to wait to 2030 odd. So that's why the zero export, limited to zero, is a very popular thing at the minute that people are talking about, is to try and avoid some of those transmission queuing issues.
Yeah. As well as technical issues, and there's like legal issues too, isn't there? So like, in terms of generally in these scenarios, everyone's unique, I suppose, but generally you'll end up with like a generator and a load customer and they're trying to come together to make some arrangement, whether that be just local on their site or potentially these private wires that's a further down the road or whatever. But in that scenario, then you still have only one connection to the grid. So there's lots of things to consider just in terms of who owns the grid connection, who signs the connection agreement and the obligations that come with that legally. You could be the demand person, but if you're signing the connection agreement, you're responsible for the generation. There's lots of tricky bits in around there that, sometimes can cause actually nearly more hassle than the technical.
Yeah, well, I would say as an engineer, the technical's black and white and we can always solve problems.
Yep.
Any of these kind of private wire schemes behind the meter, whatever you want to call them, have looked at quite a few, and I would say the vast majority of them that didn't go ahead more to do with those types of liability or legal reasons or whatever you want to call it. So exactly what you said, if who owns the connection agreement, the point of connection with the grid, because once you have generation on there, there's G99 compliance obligations. Things like, well, how are you going to set up intertripping schemes and who's paying for any upgrades to the private side substation as well?
Yep.
Is there risk that there could be interruption to the factory supply if the generator doesn't behave in the way it's supposed to behave, if it doesn't live up to its compliance liabilities? Like I kind of touched on before, I've seen some badly designed sort of G100 schemes and things where you're tripping incoming breakers to quite critical demand that you really shouldn't be. So there's definitely some things to think about.
Then there's an even more sort of terminal one ultimately where if, say, for example, the factory closed for whatever reason, who owns that connection agreement? If you're the generator, do you actually have something? Well, one, have you something to feed at all if it's zero export? Two, can you get access to say you have a 2 megawatt limit, whatever, where's the connection agreement with that and how does that all work? So there is a few tricky legal issues there. Yeah,
if you're funding a solar farm on a 20-year kind of basis, but most businesses maybe working 5 years ahead.
Yep.
What do you do if there is no factory there in 5 or 10 or 15 years to feed? Do you end up with a quite expensive stranded asset as well? So those are the sorts of things that I suppose they're not directly to us as grid engineers. They're probably more the discussions we've been involved in.
Yep.
But they're probably, to be fair, one of the more challenging bits we've probably seen. So yeah, I think probably just to summarize then, to kind of pull it all together. So, the main question we get asked, it's behind the meter. I'm going to use all electricity. Why does the grid need to know? Well, for two reasons. One's legal. You've got a legal obligation under ESQCR to obtain permission from the DNO if you're operating in parallel, even if you're not exporting. And that legal reason is there because of the technical reasons, which is point number 2. Which obviously fault level is probably one of the most prevalent ones. And then you've got some of those short-term thermal overloads or voltage disruptions that you might cause to the grid, depending on the design of your control system. And then after that, it's all more on the customer side, really. Then what does your substation look like? You might have updated protection requirements that might be expensive. You might find if you need extra VTs, CTs, or whatever, and you go to your old switchboard from the 60s, you're into a whole new substation build on your own side, and it makes the project unviable. You've got your kind of legal agreements as well. If you're coming collaborating, say you're a demand customer with, say, a solar developer.
Yep.
How does that all work in terms of grid compliance and connection agreement ownership? What does it look like in terms of protecting both parties' liabilities into the long term as well? And I think the only other one, we had one other issue we did want to say. I've seen this trip up a few projects. Is if say you're building a solar farm, it's a kilometre up the road from the factory. Obviously, you need to get your private wire between the two sites. So again, getting consents, third-party consents if it's going through third-party land ownership, if it's going up a public highway as well. We have seen some IDNO solutions come into that space in terms of the taking private wires up roadways. So you might actually be able to get an IDNO adoption and do that under statutory undertaker rights.
Yep.
So that is one potential solution to that. Again, that is more of an issue that is fairly obvious. I'd say most people would be quite aware to that type of issue. But yeah, I think as we summarise, that's all the main things.
I think that's it. And I mean, for me, when you look at this, it all makes real logical sense. Just to compare, in terms of generation and load beside each other. This is the way it's going to go. We need to maximize, the renewable energy that we have, and we need to maximize the assets that we've already built. So I think as these levers all get pulled, this is going to be something that's going to be a thing. Like, it's just the way it's going to be going forward.
It definitely is a lot more prevalent. We're having discussions on this a lot more regular basis, and it is good to see. It's not without its challenges, but as I say, most challenges, there's nothing we can't overcome.
And we're seeing crossover between our sort of sectors, aren't we? Renewables, I&C.
Yeah.
They're talking more, and then we're kind of talking in between them. So
exactly. And I think you're already starting to see EV hubs come online with battery storage and solar, and you're really seeing those technology mixes come through. Yep. Well, thanks very much, David.
Thank you.
So that's it for today's episode of the Grid Podcast. I hope you enjoyed that one and it was useful. Thanks to David for co-hosting, and we will be back again shortly with another episode. You can like or subscribe wherever you get your podcasts, Spotify, Apple Podcasts. You can also watch us on YouTube. Again, as always, please do leave comments or throw in some queries if there's any topics you want to hear covered. We do like to respond, and we do like to get the ideas in and see about topics for future podcasts. Thanks.
Cheers.